Hey everyone, welcome back to The Explainer. Today, we're going to completely redefine what you think of when you hear the words instructional technology. Seriously, by the time we wrap this up, we're going to strip away decades of assumptions and really look at the true, fascinating architecture of how humans actually engineer learning. Okay, let's dive right into this with a question. Is a 250,000-year-old cave painting a piece of educational technology? Now, if your immediate reaction is, of course not, well, you're definitely not alone. We have this massive modern bias, right? We just assume technology has to mean iPads, algorithms, complex software, the internet, all that stuff. But what if I told you that instructional technology isn't actually about the gadgets or even electricity at all? So, here's our roadmap for this explainer. We'll kick things off by defining the field. Then we'll break down the 5 domains that make it up. After that, we'll actually travel back in time to look at the ancient roots of learning, explore the audiovisual movement of the 1920s, and finally track our cognitive evolution through the 4 archetypes. All right, let's get into it. Section 1. Defining the field. What exactly is technology? To really get this, we've got to ground our exploration in academic theory for a second. We need a foundational paradigm shift about what the word technology actually means, even before we stick the word instructional in front of it. Look at John Kenneth Galbraith's 1967 definition here. He defines technology as the systematic application of scientific or other organized knowledge to practical tasks. You know what's completely missing from that sentence? Machines, hardware, equipment. None of it's there, because technology, at its very core, includes processes, techniques, methods, and procedures that are applied systematically to solve a real practical problem. And that brings us perfectly to the 1994 definition by Seals and Ritchie from the ACET, the Association for Educational Communications and Technology. They define instructional technology as the application of learning theory and emergent technologies in solving instructional and performance problems. The true goal here is literally just solving human learning and performance problems. The technology itself, it's simply the vehicle. It's just the transport we use to bridge the gap between what someone currently knows and what they need to know. Moving on to Section 2, the 5 core domains. Let's look at the AECT 1994 framework. Now, because this field is so hyper-focused on systematically solving problems, it's incredibly structured. In fact, that 1994 AECT definition breaks the whole profession down into 5 very specific interconnected domains. And this brilliantly illustrates the instructional technology cycle. You've got design, development, utilization, management, and evaluation. Think about it. Instructional technologists don't just hand out tools and hope for the best. They specify the exact conditions for learning in the design phase. They translate that into physical form during development. They carefully match learners with materials in utilization. They control the whole shebang through management. And finally, they determine if it actually worked in the evaluation phase. It's a complete living ecosystem. So let's see how this plays out specifically within that design domain. The ADDIE model is a prime example of how systematic instructional planning genuinely improves learning outcomes. You don't just wander into a room and start talking. You analyze exactly what needs to be learned. Then you design the specifications of how to learn it. Next, you develop the actual materials. After that, you implement those media and methods in context. And finally, you evaluate the adequacy of the instruction. It's not random. It's a highly organized, highly intentional procedure. To further prove just how deeply analytical and structured this field truly is, consider Robert Mager's ABCD objectives from way back in 1962. Before a single drop of instruction occurs, you must define the audience, the intended learner. You have to define the exact behavior or the desired learning outcome. You establish the condition, meaning what tools are available, and the degree, which is the standard of performance required. Honestly, this is essentially an engineering approach applied directly to human learning. All right, Section 3, Ancient Roots of Learning. We're talking pre-1600s technology. Now that we have a solid grip on the deep theory and structure, we're going to shift gears a bit. I want to transport us back in time to prove that this systematic approach to solving learning problems, it's millennial old. Just consider this historical suite for a moment. In 250,000 BC, humans were using cave art to systematically record and communicate stories. By 3500 BC, Egyptian hieroglyphs stepped in to formalize information into a written system. Over in the ancient era, the abacus was literally engineered to aid in the really complex task of calculation.
And then, jumping way ahead to 1659, Comenius published Orbis Pictus, which effectively created the very first children's picture book. Every single one of these was a profound technological advancement in instruction.
It's such an incredible contrast, isn't it? African cave paintings served as this absolutely vital medium to communicate specific ideas, maps, and symbols way, way before spoken language was ever formalized. And then you have the abacus, arguably one of the first mechanical aids for calculation. But here's the thing. Both are incredible pieces of instructional technology. Why? Because they were systematic solutions to practical human tasks, things like memory, communication, and mathematics. Now, what's really interesting here is how Egyptian hieroglyphs took painted, visual information and completely transformed it into a formal written system. I mean, this wasn't just decorative drawing. It was a full-blown instructional system combining logographs, phonetic glyphs, and ideographs. In fact, it was so complex that it required a highly specialized scribe just to encode and decode the messages. This was a massive, game-changing leap forward in how humanity stored and taught information. But instructional technology isn't just about preserving information. It also encompasses developing entirely new communication systems to solve severe accessibility problems. There's this fascinating story from the 18th century. A priest named Charles Michel de la Paix visited a home and met two silent girls. At first, he actually thought they were just being rude, but he quickly realized they were deaf, and this completely inspired him to solve this massive instructional barrier. He started observing these rudimentary signs being used around Paris, and he incorporated them into a formalized sign language to teach these children who previously had no language at all. Guys, that is pure instructional technology in action.
Section 4. The audio-visual movement. We're jumping to the 1920s and 30s.
All right, let's fast forward a bit to the 1920s and 1930s. This is an era that actually closely resembles our modern, hardware-focused assumptions about what educational technology is supposed to look like. During this time, the advancement of motion films, lantern slides, and broadcasting sparked what became known as the audiovisual instruction, or AVI movement. Tools like the record player and the radio shifted the focus heavily toward the physical instruments of presentation. Suddenly, technology was largely seen as a way to perform functions, like aiding classroom presentations or simulating a reality that a teacher simply couldn't provide on their own.
Section 5. The 4 archetypes. Let's look at the evolution of our mindsets.
To really track how our mindset around educational tools has matured since that whole audio-visual movement, we rely on Ivor Davies and Phillips' concept of the 4 archetypes. This basically maps out the evolution of how we think about teaching tools. And wow, we have made a massive leap. Educational Technology Archetype 1, or ET1, view technology strictly as hardware, like just applying tools like CCTV or projectors in a very piecemeal, uncoordinated way. Now, compare that to the modern ET4, which focuses on technology-based learning environments. ET4 is all about creating global multimedia information networks and online learning communities. We've completely moved from just sticking a projector in a room to designing an entire immersive constructivist ecosystem.
So the crucial point here is this entire cognitive evolution. Think about it. We started at ET1 with a simple hardware focus. Then we moved to ET2, which was this engineering approach heavily influenced by B.F. Skinner's programmed step-by-step learning. After that, ET3 brought in a problem-solving approach, really focusing on human performance and organizational needs. And now? Well, now we're at ET4, leveraging these incredible modern web-based environments. So yes, the physical machines evolved, for sure, but more importantly, our systematic understanding of how to facilitate learning evolved right alongside them. Which brings us right to the modern 2005 definition. Instructional technology is defined as the study and ethical practice of facilitating learning and improving performance by creating, using, and managing appropriate technological processes and resources. Listen, whether you're in a primary school, a university, or running corporate training, the ultimate goal is always human performance. The technology, it's really just the systematic process we use to get there. I want to leave you with this final, kind of provocative thought. If technology is merely the vehicle, what is your destination for human learning? As you look at your own educational challenges, just remember that true instructional technology isn't about running out and buying the newest gadget. It's about how systematically you design the journey. Thank you so much for joining me on this explainer. I really hope this structured look at the evidence has completely transformed your perspective on the tools we've used to learn. Catch you next time.